Meet Betty, Penn's revolutionary supercomputer. Imagine the transformative power when cutting-edge artificial intelligence tools are combined with supercomputing capabilities. This is the driving force behind Penn's latest technological leap, centered around a new off-campus supercomputer named Betty. If you're curious about how institutions harness such advanced systems to accelerate research, buckle up for this enlightening story. Penn's researchers are now leveraging a state-of-the-art artificial intelligence platform embodied by Betty, a supercomputer built to process vast amounts of data with exceptional speed and efficiency. This powerful machine, a sophisticated assembly of graphics processing units, GPUs, and central processing units, CPUs, was developed through a collaboration with NVIDIA, a leader in high-performance computing technology. Located roughly 30 miles from Penn's campus in Collegeville, Betty is designed to support complex AI applications that require analyzing enormous data sets, then producing increasingly accurate results as the system learns and adapts. Kenneth Cheney, Associate Director of AI and Technology at Penn's Advanced Research Computing Center, emphasized in a statement to the Daily Pennsylvanian that the creation of Betty was a joint effort involving multiple schools within Penn, including the School of Engineering and Applied Science, the Perelman School of Medicine, and the School of Arts and Sciences. He pointed out that the demands of modern AI research have grown so significantly that no single school can sustain the necessary computational resources alone. Adding to this perspective, Marilyn Ritchie, Vice Dean for AI and Computing at Perelman, highlighted that Betty's launch marks an important evolutionary step, allowing different disciplines to grow collectively. Her view suggests that AI technology is expected to become a fundamental part of research across diverse fields. She believes that what appears to be specialized GPU computing today might very well become a standard tool in most research areas in the near future. This development also signifies a shift towards shared computing infrastructure at Penn. Instead of individual labs investing heavily in their own servers, which Ritchie described as both expensive and inefficient, researchers now have access to a centralized computational resource managed by PARC, Penn's Advanced Research Computing Center. Ritchie explained that not only do labs often spend significant time and money acquiring and maintaining their own servers, but these machines tend to be underutilized, sitting idle much of the day. The shared model embodied by Betty ensures better utilization of resources, maximizing the computational capacity available to researchers and enabling large-scale work that would be impossible within a single lab. Additionally, situating Betty off-site was a practical choice. The system requires specialized cooling and energy, components that are challenging to implement within the constraints of campus infrastructure. Ritchie pointed out that Betty needs specialized energy and cooling systems, which would be difficult to supply on campus. Cheney added that Betty's current energy consumption is about 1 megawatt, a scale that is simply unmanageable in an urban environment like Philadelphia. Despite the physical location, Ritchie reassures that Betty remains fully accessible to Penn's entire research community through network access. So he also stressed that Betty's deployment is just the beginning, opening the door to a future full of promising innovations and increased collaborations, all powered by this advanced supercomputing resource. Would you agree or challenge the idea that shared high-performance computing like Betty will define the future of university research? Or do you think individual labs should still strive for their own supercomputers? Sharing your thoughts could spark some fascinating conversations. Inside UPenn's Betty, the supercomputer powering an AI revolution. Imagine a technological powerhouse hidden away from the bustling heart of Philadelphia. A supercomputer named Betty that's quietly revolutionizing artificial intelligence research at the University of Pennsylvania. But here's where it gets interesting. Betty isn't just any supercomputer. It's a state-of-the-art facility located 30 miles northwest of Penn's main campus, connected by twin fiber data lines for seamless communication. This off-campus setup might seem unusual, but it's a strategic move to accommodate Betty's immense energy demands and processing capabilities. Built by NVIDIA, a global leader in semiconductor technology, Betty consists of a stack of central processing units and a SuperPOD of graphics processing units, all integrated with advanced data storage solutions. This configuration allows Betty to handle complex AI models that analyze vast amounts of data, including videos, images, and what sets Betty apart is its ability to learn and improve with each query, making it an invaluable tool for researchers pushing the boundaries of AI. Housed in a 3-story data center in Montgomery County, Betty's presence is nothing short of awe-inspiring. It generates more noise than a commercial jet taking off and consumes enough electricity to power 1,000 homes. The site is named after Frances Betty Holberton, a pioneering Penn computer scientist who made significant contributions to early computing. Located within Flexential Corp's data center in Collegeville, Betty serves as a cornerstone of Penn's Advanced Research Computing Center, helping the university stay ahead in the competitive landscape of academic research. The importance of having access to such powerful computing resources cannot be overstated. As top universities vie for grants and talented students, to address this challenge, Penn decided to invest in Betty, a project that was approved and built in record time, just under a year, following extensive discussions among university deans and researchers. There's definitely an arms race in computing, explained Michael Borda, Penn's Associate Vice Provost for Research. We needed to increase our capacity significantly, and Betty provides us with the tools to do that. By quadrupling the university's computing capacity, Betty ensures that researchers have the resources they need to tackle increasingly complex problems in fields ranging from medicine to robotics. One of Betty's most impressive features is its ability to process large volumes of data quickly and efficiently. For instance, researchers can now analyze entire videos, examining hundreds of images per minute, which was previously impossible with existing systems. This expanded computational capability is crucial for advancing AI technologies in areas such as natural language processing, video analysis, and audio recognition. Interestingly, Betty's location on the outskirts of Philadelphia is not arbitrary. Power supply constraints in the city made it challenging to accommodate the supercomputer's enormous energy demands. By situating Betty away from the urban core, Penn can leverage nearby power plants, such as the Limerick Nuclear Power Station, ensuring a stable and reliable energy source for its operations. Flexential Corp, the operator of the data center, has taken great care to ensure that Betty's operations are resilient and uninterrupted. The facility is equipped with multiple backup power generators, ensuring that even during power outages, critical research can continue without disruption. This level of redundancy is essential for maintaining the integrity and reliability of AI-driven projects. Beyond its immediate impact on Penn's research efforts, Betty serves as a model for other universities facing similar challenges. By outsourcing its computing infrastructure, Penn can focus on its core mission, advancing knowledge and training the next generation of researchers and technologists. As AI continues to transform industries across the globe, facilities like Betty play a vital role in shaping the future of scientific discovery. In conclusion, Betty represents more than just a supercomputer. It's a symbol of Penn's commitment to innovation and excellence in research. Its off-campus location, cutting-edge technology, and robust infrastructure make it a unique asset in the rapidly evolving field of artificial intelligence.